We are going to look at analyzing an algebraic function, a cubic function, which is x cubed minus 2x squared minus 11x plus 3. And we're going to use the TI-Nspire calculator to help us with this analysis. And we're going to look at the graph of the function. We're going to look at and explore a table of values for the function. We want to be able to find the y-intercept, the x-intercepts. We're going to talk about the domain and the range, and then also the zeros of the function. So as I said, we're going to use the TI-Nspire calculator to help us do that. And one of the important things of using that is being able to type the function in correctly. So I'm going to go to the home page. I'm going to add a calculator page to it, and then I'm going to type my function in. I'm going to start out with the x on the calculator, and then I have to use the exponent key because I have a cube, so I use the exponent key, and then I put a 3 in because the exponent is a cube. Now, notice that the cursor is up with the 3. In order to get that back down on line with the x, I have to use the right arrow. If you don't do that, it's going to continue to type your function up there in the exponent category, and it's not going to graph correctly. The next part of the function was minus 2x squared. Now with the squared, we have an x squared key. You don't have to use the right arrow. If you do, the calculator will go ahead and assume that you meant to hit enter, and it'll graph the function and not let you finish it out. So don't hit the right arrow key this time. Instead, we're going to finish the rest of the equation. It was a minus 11x plus 3. Once I have the equation entered in correctly, then I press the enter key, and there is the graph. Now, if you will notice, the function is kind of in the way of the graph itself. So what I can do is I can hover over the function, and I can hold the mouse button. If I select it, if I click it, it's going to select it. But if I hover over it with the mouse, I can hold it or press the mouse button and grab the function and drag it. Once I get it to the place where I want it to be, I can hit the escape key and turn it loose. So I've kind of moved the function over out of the way. So basically, this is the graph that we wanted. If I want to see a little bit more of the graph, I can go back to the menu key. I can go to the window Zoom, number 4. And in this case, to see more of it, I want to zoom out. So I'm going to choose number 4 to zoom out. And normally it's a good idea to get toward the origin and just click, and it's going to zoom out where I can see a little bit more of the graph itself. Okay? So now I can kind of see what the graph looks like, and it kind of favors the cubic family. It has that general shape. And so I have the graph now. The next thing that I want to do is, if you recall, we talked about we wanted to see a table of values. And particularly when we wanted the values of -2, when x is -2, -1, 0, 1, and 2. If we did a little t-table for it, it would look something like this. We'd have our x here, our function f of x. Because it's kind of long, I'm not going to write it out. I'll just let that represent it. And we want to evaluate it for -2, -1, 0, 1, and 2. Now, of course, if we didn't have a calculator, we could manually substitute in the values everywhere we have an x in the function, and we could use the order of operations, and we could come up with the answer. If we had a calculator and we're trying to do something like this, and let's say we're on an ACT and we need to go a little bit faster, then what we can do is use our calculator. While we're on the calculator page, I can press the control button, and I can press the letter T on the keyboard, and that's going to give me a table. That's the shortcut keys to get a table in a split window with the graph. Now, if you'll notice, I can use the arrow keys on my calculator and arrow up, or I can arrow down and see different values. And I'm interested in the value when x is -2, first of all. And notice when x is -2, the y value is 9. So I'm going to put that in my table. And then I'm going to go on down, And I'm interested in when the x value is -1, the y value is 11. When the x value is 0, then of course my y value is going to be 3. When my x value is a positive 1, my y value, or my function value, is a -9. And then finally, when my x value is a positive 2, my y value is a -19. So I put together a little bit of a table, just a little snippet of what the table of values looks like. And that's part of doing the functional analysis. The next thing that I want to look at, and I have to look close at the graph, I want to know what the y-intercept is. And of course the y-intercept is where this graph is going to cross the y-axis. Now I don't need my table anymore, so to get rid of it I can go to Control and T, and my table's gone. Now it's kind of tough for me to tell here on this scale where it crosses the y-axis, so I may need to zoom back in just a little bit. So I could go back to my menu, go back to Windows Zoom, and I can go to Zoom In now. I'm going to go back to the center, and I'm going to click it once, and it zooms it back in again. I'm going to turn that tool off, so I hit the Escape key to turn it off. And now if we look really close at this graph, we can tell that it crosses roughly at x equals 3. I also know this by experience, by looking at this function. I always know with the function, if I have a constant term at the end without a variable, whatever that is, that's going to be my y-intercept. So my y-intercept in this case is going to be at y equals 3. Okay? All right, now the next item, we want to look at the x-intercepts in this, where it crosses the x-axis. So again, I can use my calculator to help me do that. I may want to zoom in one more time here, so I'm going to go back to my window zoom and zoom in. I'm going to go back to the center. There we go. That gives me a little closer look. I'm going to hit Escape to turn that off. Now, if you notice by looking at this, I can't really tell exactly where it crosses the x-axis. I can see it here, but I don't know exactly what that point is. But the calculator has a tool on there to help me with that. I'm going to use what's called the intersection tool. To get to that tool, I go to Menu, go down to Geometry. I'm going to use Points and Lines, and it's number 3, the intersection points. To find out the intersection points, first of all, I've got to go over to the function itself, and I want to click on it. And then once I click on it, if I'll go down to the x-axis, click on it, notice the points that appear. Now, I still don't know what those points are, but it gives me points where that is, but I can identify them. So if I go back to the menu key one more time, go to Actions, and then Coordinates and Equations. If I go and hover over that point, notice it'll tell me what that point is. I can click the mouse button. That's this button right here in the middle. I can click the mouse button while I hover over it. I can move it, click one more time, and I can lay that point down. I can see that one of the x-intercepts is at -2.63. If I go to the next intercept, do the same thing. Hover over it, click it, move it kind of out of the way where I can see it, click again. It lays that point down. Another x-intercept is going to be at 0.262. And then the final point, hover over it, click with the mouse button, move it where I want it, click with the mouse button again. It puts that point where I can see it, and the coordinate for it is 4.36. So those are my x-intercepts. So I have x-intercepts at x equals -2.63, I believe it was. Is that right? Yes. And a 0.262. And then at x equals, let's see, it was 4.36. All right, so those are my x-intercepts where it crosses the x-axis. The next thing I wanted to look at was my domain. Remember from Algebra 1 that domain is simply all your x values that are included in the graph. So to kind of help understand this, and this is one of those things that's a little bit difficult to understand, I'm going to go back and use another tool on this kind of temporarily. I'm going to go to Menu, and I'm going to go to the Trace function. And I'm going to do a graph trace. Now, it always puts it at the y-intercept, another way to find the y-intercept. And notice again, the y-intercept, the y value there is 3. If I start using my arrow keys and following this graph to the right or to the left, notice that it gives me a set of coordinates down here. And the farther that I go to the left, the smaller those x values get. Matter of fact, I could keep going and going and going and going, and it's never going to stop. It'll go forever. Well, the way that we say that mathematically is we have a term called infinity. In this particular case, it's in the negative direction, so we call that negative infinity. So the domain in this case, from the left side, it's coming from negative infinity, and we write it that way. And we use a parenthesis because we're going to use set notation. We can't put an exact value on it, so we use a parenthesis instead, and then we use another, we need a comma in between, and then we look at the right side of the function. So if we start arrowing back to the right, if you'll notice the x values, they keep getting bigger. And the farther we go to the right, the bigger the x values get. And matter of fact, we can continue to the right and continue and continue. Matter of fact, there's no end. It will continue on as long as we want to keep pressing the button. It will keep going. Again, the mathematical term that we use for that is infinity. So the domain, which are all the x values, are from negative infinity to positive infinity. And we close that with a parenthesis. Now we're going to look at the range. The range of the function is going to be, and let me get back to the original function. Let me do that. So let me go back to Windows Zoom. I'm going to zoom back out till I see the regular function. And I've kind of zoomed out too far. So now now that I'm at the center, let me zoom back in so we can see the original function the way that it is. Okay. I'm going to turn it off. I'm going to move some of these points because they're all kind of jumbled around in here. There we go. Now, domain or range is talking about your y-axis. And so if you look at this, if you noticed a minute ago when we traced it out, it had all these x values that continue to go, but it also had y values to go along with it. So if you trace this function out again, as far down as you want it to go to the left, it's going to continue to have y values that keep getting smaller and smaller. We call that it's very similar to the domain. The range on this then is going to be, again, from negative infinity, because those negative values are going to continue and they're going to get smaller and smaller. And then as we move to the right of this function, the y values, of course, they're going to go up to a point. If you look at the graph, it's going to go all the way up here. It's going to turn around and then go back down. To here, to this lowest point, and then it's going to go back up, and then they're going to continue to get larger and larger and larger and larger. And much like the domain, the range is going to be from negative infinity to positive infinity. And then the last piece of information that we want to look at for this function in this analysis is we want to know about the zeros of the function. And the good news is that since we've already found the x-intercepts, we've really already found the zeros as well, because the zeros of the function, the real zeros of the function, are defined as the x-intercepts, or where the graph crosses the x-axis, which we already found out. So the zeros would be where every one of these points are that we found a minute ago. So the zeros of the function are going to be at x equals a negative 2.63, x equals a 0.262, and then x equals 4.36. I don't know if you noticed earlier when we used the calculator to help us find those intercepts, but the y values at those points, and let me just use that tool one more time to show you, to demonstrate. It was actions, coordinates, and equations. When I hovered over that point, the y value there was 0. That's why it's called a 0. Where it crosses the x-axis, the y value is 0. Therefore, that is the zeros of the function. And that kind of completes our functional analysis for this particular cubic function.